Hello and welcome to our video Things to Know About Flocking. We are the company Maag Flock with headquarters in Mössingen, Germany. We are a machine manufacturer for flocking plants, machines, basic flocking equipment and testing devices. On this YouTube channel you will find further videos about flocking, about our equipment and devices, their operation and our video format Flocky Friday, where we will upload a new video every Friday in which we flock something. More information about what we do and latest news you can find on our social media channels Facebook, LinkedIn, Instagram and here on YouTube. Today's video is about a general overview of flocking, how it works, what flocking can do and examples of use. Flocking is used in an electrostatic process for technical optimization and finishing. The application of flock is universal. The flocking process is structured as follows. In the first step, the substrate to be flocked is pre-treated. This is done to pre-treat the surface condition of the substrate so that the adhesive and the flock fibers will hold later during flocking. In the second step, the adhesive is applied by brushing, spraying or rolling, for example. This is followed by flocking, in which the flock fibers are anchored in the applied adhesive by the aid of an electrostatic field. For this purpose, electrostatic devices can be used or an electrostatic pneumatic device that work with the aid of an air supply in order to also flock molded parts optimally. This process can take place manually as well as in a semi or fully automated flocking plant, from the first step of the pre-treatment to the last step of drying and cleaning. After flocking, the substrate is pre-cleaned to remove the first loose flock fibers. Afterwards, the flock substrate is dried and final cleaning takes place. Any material can be flocked, for example, plastic, wood, foam, rubber, paper, foil, glass and many more. During the flocking process, the flock fibers anchor themselves vertically in the adhesive. The fibers form a layer over the substrate covered with adhesive. After flocking, only about 10% of the surface is covered with fibers. This is due to the voids or spaces between the fibers that form during the electrostatic process. Visually and haptically, a completely flocked and velvety surface is produced. You will get more detailed information about electrostatics and flocking in another video from us. You can also look forward to the next video on the subject of flock fibers and adhesives. Now to the question of what flock can do. Flock can be used to increase the sliding properties, to achieve an increased abrasion resistance, to scratch protection, to reduce noise and surface enlargement. Flock creates an anti-slip effect and a damping effect. Flock serves for sealing, the tolerance compensation, noise protection, insulation, heat distribution and much more. I will go into some of these examples in more detail below. How can flocking increase or minimize sliding? Friction occurs when two objects have different surface textures. For example, rubber and glass. Rubber has a very rough surface texture and glass a very smooth. When the two objects rub together, frictional forces are created, called static and sliding friction. This phenomenon can occur in your own household when moving furniture. If you move a wooden cabinet on a tiled floor or similar, friction occurs. This can be reduced by applying felt adhesives or flocked pieces of foil, which reduce friction and thus increasing sliding. Flock can achieve noise reduction. This occurs due to the multiple breaking of sound waves by the flocking structure. This is due to the fact that the flock fibers swallow airborne and structure-borne sound as so-called discontinuities. The fibers absorb sound through their surface texture and the voids between the fibers. How can flock compensate tolerances? The flock fibers on the surface of the substrate act as gap fillers. By aligning themselves vertically on the substrate, the small fibers can efficiently bridge small gaps by bending, filling the gap between materials like a spring. Vibration compensation, thanks to a flocked surface, also works. The fine fibers on the surface of the flocked substrate have a damping effect like small springs that swallow vibrations. How can flock be used to prevent stray light? The flock fiber structure has an absorbing effect by breaking the light waves many times. This is due to the large amount of fibers incorporated on the flock surface. Due to their nature, these cannot reflect light waves and thus stray light can be minimized. Surfaces can also be enlarged with the help of flocking. The free spaces between the flocking fibers can be used as a depot. The large number and vertical orientation of the fibers and their structure ensure that the surface of the substrate is enlarged during application. This is mainly used in the production of painter rollers or cosmetic and medical applicators. How can flock contribute to insulation? As I said before, the incorporated flock covers only about 10% of the flocked surface. The still air between the fibers or in the voids creates an insulating effect because air is trapped in a very small space and it's a poor conductor of heat. Thus, heat is retained within a flocked object. In addition, the insulting effect of the flock shifts the dew point and prevents condensation. A flocked surface can also serve as scratch protection. The flock fibers, in combination with the adhesive, form a solid layer over the substrate and thus protect it from environmental influences such as sharp objects. Depending on the choice of fiber length and diameter, flock can achieve a filter effect that can be used in different ways. The longer the fiber, the greater the spacing between the individual fibers on the flocked surface. This spacing can then be used as a filter for bacteria or dirt. The shorter the fiber, the smaller the spacing, and the flocked surface forms a cushion that repels even the smallest particles. One of the main properties of flocking is that it improves the feel. The vertical orientated flock fibers form a surface texture that turns out soft or hard, depending on the flock fibers used, fiber length and diameter. The smaller the diameter and the longer the fiber, the softer, and vice versa. This is mainly used for products that later come into contact with skin, body or other sensitive surfaces, but also for doormats when a rougher surface is desired, which can create a filter effect. By choosing small, short fibers, a lotus effect similar to the filter effect can be achieved. By using short fibers, the distance between the fibers becomes smaller. Since the structure is small porous, liquids roll off the surface and dirt particles are minimized at the same time. Flock can reduce water resistance. Flock can ensure that resistances are minimized. The smaller the flock fiber, the smaller the spacing between the fibers, the more optimized the surface finish of the flocked substrate. Using a boat hull as an example, flocking serves to provide resistance to seaweed and others, as well as anti-fouling and improve the gliding of the boat in the water. Flocking a surface to improve the visual appearance. Flocking a surface can improve the value and aesthetics as well as refine objects. There is a choice of flocking fiber parameters depending on the desired surface texture and color and additional function. The formation of condensation can be prevented by flock because the vertically anchored flock fibers have air cushions. This cushion prevents condensation. As next, I would like to present some concrete application examples of flocking. Two objects I'm already holding in my hand are from our largest customer sector, the automotive industry. Springs are flocked and installed, for example, in trunks to reduce noise. The flock window rubber profile is used for sealing, improving sliding properties and noise insulation. In addition to springs and profiles, center consoles and glove boxes are also flocked in cars. The flocking of this component serves a better haptic, scratch and rattle protection.
Gegenstände, die sich beispielsweise im Handschuhfach befinden, nicht klappern können und dass das Handschuhfach eben auch vor äußeren Einwirkungen geschützt ist und nicht so schnell Kratzer oder Ähnliches erleidet.
In the building industry, you can also find flocked parts. These are, for example, guide rails of sliding doors or windows, as well as flocked raw materials like styrofoam or similar. These are used for noise reduction, surface enlargement or a better haptic. Another field of the application is the flocking of paint rollers. This serves to increase the surface area to ensure frictionless and streak-free application during painting work. Painting rollers as well as other tools can be flocked. This serves the avoidance of heat transfer. In the field of textile and fashion, shoes can be flocked among other things. This serves on the one hand the optical and haptic refinement, but can also be used to flock heels and walking surfaces to reduce the risk of slipping and to improve adhesion. T-shirts and other fabrics, such as sertins or similar, can be flocked. This serves the refinement, a higher haptic and to highlight design elements. There are no limits to the freedom of design. To remain briefly in the related area of textiles and fashion, clothes hangers can also be flocked. This serves an anti-slip effect depending on the material of the garment and prevents deformation. The next application example are swaps or tips. These are mainly used in the medical and cosmetic field. In the cosmetic field, they are used as applicators for lip gloss. In the medical field, flocking is used to produce corona test strips. In the field of haptic and optical finishing, various packaging can be flocked, regardless of whether paper packaging, book covers, flacons, cosmetic packaging or others. Furniture can also be flocked, whether sofas, lamps, beds, curtains or carpets. Here too, there are no limits to the freedom of design. Many artists also flock their works of art to achieve a higher value and a more beautiful feel and look. Porcelain and glass can also be flocked. This is mainly used for microwave dishes because of the insulating effect. In the field of sound, so-called microphone windscreens are flocked, which, thanks to the flocking, ensure better sound and voice quality during recordings. Toys can also be flocked, for example wooden building blocks for noise reduction and better haptics, but also coloring books and dice cups. Another well-known application is flocking in model making, for example to create railroad landscapes. This brings me to the end of today's video. I would like to thank you for your attention. I would be happy if you leave a comment if you have any questions or suggestions and give the video a like. And you can already look forward to the next video about flock fibers and adhesive. Thank you and see you next time.